Welcome all to this special webinar event in collaboration with Holy Ghost and Fullscript. I'm Amy Regan from Fullscript, and I'm so glad that you joined us today. A few housekeeping notes. Please place all questions you have in the Q&A box for a chance for them to be answered during the presentation. The webinar is being recorded, and the recording will be sent via email to all attendees and registrants. And there's a copy of the presentation slides in the handouts section. Today, we are joined by Amy Harvill, nurse practitioner and the Global Scientific Engagement Lead for Eye Health and Holy Ghost, Dr. Alex Keller, the medical director here at Fullscript, and Dr. Natacha Montpellier, our medical science liaison, also from Fullscript. Welcome, everybody.
Thank you. Much appreciated. All right, before we get started, I want to give everyone a quick overview of what to expect today. For those of you who've been tuning into our webinars lately, you'll notice that we're starting to adopt more of a conversational style webinar. So it's kind of like a cross between a podcast and a webinar. And that's based on feedback that we've received that people were keen to have more questions answered throughout the presentation instead of waiting until the end. So we've prepped Amy today to know that we're going to be interjecting with questions as we go. So Dr. Natacha and I are here basically as your voice. So feel free to drop questions and we'll make sure they get asked and answered as we go. The other thing you'll notice is that we're really leaning into ingredients and the evidence behind those ingredients going forward. Part of that is because some of you may know there's limitations to how we talk about evidence as it relates to products in the natural health products and supplement space. So by keeping the products out of it and just focusing on the ingredients in this case, it allows us to talk more technically and with more reference to the evidence. So we'll guide you as we go here in how to find the associated products in the Fullscript catalog and how to use those in practice. But for today, we're going to be really leaning into the unique and special ingredients that Amy is here to educate us on. At the end, I should go to the next slide here. At the end, we'll also be talking about an ingredient-based protocol that contains the ingredients that we'll talk about today. So for today, we're going to talk first about an overview of digestive health, give us the Coles notes, and then Amy's going to talk about the two unique ingredients that we human milk oligosaccharides and this unique probiotic strain, Bacillus coagulans unique IS2. We're going to talk about the effect on the microbiome of both and the pre and clinical evidence for both. Summary, talk about the brand behind these ingredients, Holy Ghost. And then, like I mentioned, we're going to talk about an ingredient-based protocol at the end. So with that, let me pass it over to Amy. And Amy, you take it away, and we'll interject along the way with some questions.
Wonderful. Thank you so much for having me here today, first of all. I really appreciate the opportunity to talk to you about these ingredients and their effect on the human digestive system and the human microbiome. So I'm going to start off by talking about digestive issues in general. Functional GI disorders are highly prevalent. We know there's a global incidence of around 11%. And in the US, it's actually a much higher number, with approximately 25 to even 30% of the US population being affected. For many patients, these are recurrent and chronic issues with symptoms such as abdominal discomfort, bloating, gas, and abnormal bowel movements having a significant impact on their quality of life. In addition to the burden of the physical symptoms, the indirect impact can also be significant, with consequences such as decreased work productivity, increased absenteeism, increased healthcare utilization, loss of leisure time and PTO, and then financial impacts such as lost earnings or increased healthcare-related expenses. Healthcare providers have really struggled for a long time to find effective solutions to all of these problems. And part of the issue is that the etiology is not really well understood. It's likely multifactorial, including things like genetics, visceral hypersensitivity, gut dysmotility, and alterations in the gut-brain axis, all factors that also affect changes in the gut microbiome. So what are some of the therapies that have been utilized for digestive issues in the past and currently? These are some of the common therapeutic options for managing these issues, including things like dietary changes, supplements, and pharmaceutical agents. Many of these, like antidiarrheals and laxatives and antispasmodics, treat the symptoms but don't actually address the underlying cause of the digestive issues. Others, such as dietary modifications, prebiotics, probiotics, and antibiotics, all have something in common. They exert an effect on the microbiome. So talking a little bit more about the microbiome, we'll start off just with a couple of definitions. The microbiota, that refers to the individual microorganisms or type of microorganisms that are found within a specific environment. These are typically thought of as bacteria, but also include other classifications such as fungi and viruses as well. The term microbiome refers to the collection of microorganisms, along with their structural elements such as proteins, lipids, and DNA, as well as the metabolites they produce and the environmental factors that influence how they interact. The gut microbiota of bacteria is estimated to possess an astonishing number of over 200 million genes. That's almost on par with the total count of cells in the human body. This intricate microbial community really plays a pivotal role in regulating a wide range of biological processes. And because of that, it exerts a really profound influence on human health and overall well-being. So talking about how the microbiome affects us. These are some of the biological processes that are affected by the microbiome. First off, talking about barrier function. This is really the gut's first line of defense. It provides a physical and chemical barrier against toxins and pathogens that are encountered in the GI tract. The integrity of this intestinal epithelial barrier really heavily relies on the commensal microbiota. Microbes produce mucins and other factors that help to strengthen the mucus layer that protects that epithelium and tightens the junctions between those cells in the intestine. When it comes to neuroendocrine communication, hormones and neurotransmitters like dopamine and norepinephrine, as well as histamines, are all generated by commensal gut microorganisms. These play a role as signaling molecules to stimulate the microbiota gut-brain axis. Research has shown that dysbiosis and low-fiber diets have been associated with increased levels of stress, anxiety, and depression. They also play a role in nutrient production and absorption. Microbes produce short-chain fatty acids, which are derived mainly from complex carbohydrates. Some bacterial strains produce enzymes like lactase and bile acid hydrolase, as well as vitamins like the B vitamins and vitamin K. Bacteria also play a role in immune functions through a lot of different pathways affecting inflammation and allergic responses. And lastly, gut motility and digestive function are really impacted by microbial diversity and abundance. Probiotics also regulate pH in the GI tract, which, in addition to affecting the microbiome, also impacts the breakdown and absorption of nutrients. And then finally, some microbes actually provide enzymes and biochemical pathways that actually help humans to obtain nutrients from their foods. So that's how the microbiome affects us. Now, how do we affect the microbiome, right? Because it's a two-way street. Just as they exert an effect on us, their hosts, we also exert an effect on them. And the things that we do can lead to dysbiosis or an imbalance in the microbiome. So dysbiosis is associated with a large number of health disorders across different body systems. With GI tract issues in particular, patients have been demonstrated to have dysbiosis with less microbial diversity, larger proportions of pathogenic bacteria, and fewer commensal or beneficial bacteria. In particular, reduced abundance of bifidobacteria is thought to contribute to bowel symptoms by driving inflammation and increasing the porousness or permeability of the bowel wall. This helps to contribute to increased pain sensitivity and also helps to contribute to abnormal stool consistency. So this graphic illustrates some of the factors that can disrupt that microbiota, including alcohol consumption, lack of physical activity and sleep, stress and smoking. For infants, the mode by which they were delivered, whether it was C-section or vaginal. Diet, this is a huge one. The standard American diet, which I love that it abbreviates out to SAD. It's a diet that's really high, as I'm sure most of you know, I'm preaching to the choir here, high in processed corn, soy, sugars, artificial ingredients, saturated fats. It's also really low in fiber. So these low nutrient foods really drive down that microbial diversity and increase inflammation. And then finally, medications and antibiotics. These can really wreak havoc on the microbiome, with the resulting dysbiosis leading to conditions such as yeast overgrowth, diarrhea, and even C. diff. It can actually take 6 months to a year for the microbiome to recover after being treated with medications like this. So what can we do that might actually help? Biotics are substances that actually help to support a healthy microbiome. So again, starting with a couple of definitions here. Probiotics are, I'm sure everyone's familiar with these, but they're live microorganisms that when administered in adequate amounts confer a health benefit. So essentially, these are the good bacteria that live within us. Prebiotics essentially are food for those good, beneficial, or commensal bacteria. The actual definition is a substrate that is selectively utilized by host microorganisms to nourish the good bacteria already present in the gut microbiota to deliver a health benefit. Often these are fibers, but not always. And additionally, not all fibers are prebiotics. And then last on the list here is postbiotics. Postbiotics are a newer classification, although they've actually been around for many years. They used to be considered to be part of the probiotic category, but they were defined by a consensus statement of the International Association of Probiotics and Prebiotics, or ISAP, in 2021 as being a preparation of inanimate microorganisms and or their components that confer a health benefit on the host. Basically, what they are is microbial cells or components that have been inactivated, usually by heat or freeze drying, with or without their metabolites and other components. Now, symbiotics are actually a combination. So a symbiotic is really just what it sounds like. It's a mixture comprising live microorganisms and the fuel to nourish select microorganisms that delivers a health benefit for the host. So it's a combination of a probiotic with a prebiotic. So talking a little bit more about prebiotics, we're going to get into this category of human milk oligosaccharides. These are a family of complex carbohydrates that are found in very high concentrations in human breast milk. It's actually the third largest component of human breast milk, even though it's something that is not food for us. They're non-digestible by humans, but as a prebiotic, they're the fuel for the microbes that make up our microbiome. Now, human milk is actually very different from the milk of other mammals. It's got a higher concentration and complexity of structures than any other type of milk. And most of the structures that are found in human milk are actually not found in other animals. There have been over 200 different oligosaccharides identified in human milk, as opposed to around 40 in cow's milk. Additionally, the ratio of the different types of oligosaccharides in human milk is very different from animals. For example, 80% of the oligosaccharides in cow milk are sialated, meaning they contain sia residue, whereas the majority of the oligosaccharides in human milk are fucosylated. Now, what does that mean? We're just going to talk about that a little bit more on this next slide here. So, as I mentioned previously, cow's milk and human milk have a really different composition of oligosaccharides, with cow's milk having primarily sialylated oligosaccharides. In humans, only 12 to 14% of the HMOs in human breast milk are this type. It's primarily made up of these other two types that you see on the left-hand side of the slide. These are neutral HMOs, and that can be further broken down into categories of fucosylated, meaning they contain fucose, or non-fucosylated HMOs. So today we're going to focus primarily on two types of HMOs. The first one is 2-fucosylactose, or 2FL for short, and that's a fucosylated HMO that is the single most abundant HMO in humans. It comprises 30% of the total HMOs in breast milk. The second one is lacto-N-neotetraose, or LNNT, and this is a non-fucosylated HMO, which is the second most abundant. These two are typically found in human milk in a 4-to-1 ratio. They've been studied the most widely of all of the HMOs. They can be produced on an industrial scale, which is important if we're going to be trying to use them as supplements. And they've been shown to be safe in all ages from infants to adults. So for these reasons, they have become the HMOs that are utilized most frequently in infant formulas. in this next slide, we're going to talk a little bit about the history behind HMOs. This slide is supposed to build. I'm not sure if it's going to work properly here. No, slide is not building for us. All right, so you're just going to hear me talking a lot about, for a while, about the history. So with regard to the history of HMO research, as early as the late 1800s, pediatricians noted that intestinal bacteria had an effect on infant physiology, and chemists around that same time discovered that human and animal milks had different carbohydrate compositions. In the 1950s, HMOs were actually identified as the bifidus factor that contributed to the beneficial effects of human milk. It was really why human milk had so much better health benefit than animal milk for human infants. But it wasn't really until around the year 2000 that HMO research really started to take off. Since that time, there's been a really significant increase in the number of studies, at first primarily in infant populations. And then in around 2010, scientists figured out how to create HMOs in a lab. So then things really started to accelerate. The first infant formula containing HMOs was introduced in 2016. And shortly thereafter, researchers began focusing more on what benefits HMOs might have in non-infant populations as well. So we already know that in infants, HMOs are the primary determinants of the gut bacteria. They help to build that healthy gut wall barrier and gut immune function, and they bind pathogens like viruses and harmful bacteria. So we really have a pretty decent understanding of the benefit of HMOs in infant populations because of our experiences looking at breast milk. But we're really just starting to explore the potential benefits beyond infancy. In non-infant populations, HMOs have been shown to specifically increase bifidobacteria abundance, increase the concentration of the metabolites that are essential for gut barrier functioning and immune modulation. So today we're going to talk about those non-infant populations a little bit more, and we're going to review some of the data supporting the benefits of HMOs. So questions about the microbiome space before we move into the clinical data piece or the preclinical data piece?
Yeah, I'm going to jump in with two questions here. First is, can you talk a little bit more about the method of extraction or preparation of HMOs?
So the HMOs actually were initially identified from human milk, but it was a matter of determining how to create them in a lab. And that really didn't come about until around the year 2010. I'm actually not that familiar with the particular process.
So what you're saying, though, is just to clarify for people that we're not extracting the HMOs used in supplements from human breast milk, that they're being created in a lab to mimic what the
correct. Yeah, it's really a matter of scale. I mean, you'd need an awful lot of breast milk to be getting enough HMOs to be making supplements. So it's really, you have to be able to create them in a lab in order to be able to have the sort of manufacturing and production capabilities to be utilizing as a supplement.
Right. Okay. And then the second one is for people who have concerns around either lactose or the proteins in milk. So lactose being more on the fermentation side, or proteins as relates to typically cow's milk. Are there any concerns for people if they're consuming a product like this, if patients have sensitivity to either of those?
That's an excellent question. So with regard to lactose, the issue is really, it's a matter of scale. Most people who have lactose intolerance can actually tolerate a very small amount of lactose. And when it comes to the amount of lactose that is in a supplement, for example, it's such a small amount that it doesn't typically affect those patients at all. So patients with lactose intolerance shouldn't have an issue. Because there is some lactose derivation, though, if it were a true protein allergy, then I could potentially see that being an issue.
Okay, so shouldn't be a concern, but not 100% sure on the protein sensitivity side.
Right, but for those lactose intolerant patients, shouldn't be an issue at all. And they were actually allowed to be included in the clinical studies because the amount of lactose is actually so small.
Perfect, that's good to know. Okay.
Great. So let's talk about some of the preclinical data. And this really helps us to understand the mechanism of action of HMOs. So the impact of HMOs on the metabolite profile and composition of the gut microbiota was actually looked at using something called the SHIME model. This is a simulator of human intestinal microbial ecosystem. This was a multi-compartment in vitro GI model of the human gut. Investigators used this model to evaluate the impact of 2FL, LNNT, and a mix of the two HMOs over a 3-week treatment period followed by a 2-week washout period. This slide contains some graphs showing the effects of HMOs on the composition of the gut microbiota. So the 2FL and mixed treatments, as you can see over here in those graphs on the left-hand side, but not the LNNT alone, actually led to a substantial initial increase in bifidobacteria. That's represented by the dotted line at the bottom of each graph. And remember, the bifidobacteria are the good guys. These are the ones we want to try and build up and increase in the GI tract. This tapered during the 2nd and 3rd week of treatment. All 3 treatments caused a decrease in the bacteroidetes level in the vessels as well in that 1st week of treatment. That's represented by the solid line within with the circle. Now, those are actually the pathogenic or bad actors. They're the organisms that tend to lead to more adverse effects in the human system. So the decrease in those actually appeared to occur at the profit of the bifidobacteria for both the 2FL and the mixed vessels, meaning that the HMOs actually caused the composition of that microbiome to shift to contain more of the beneficial bacteria and fewer of the pathogenic bacteria, which is really an ideal situation for the human gut. So this one talks about not the microbes themselves, but the actual metabolites, so what those microbes create. So in the same study, the investigators looked at the effect of HMOs on the metabolites that are found within the microbiome of that simulated human gut. And treatment with all 3 HMO formulations, the 2FL, LNNT, and the combination of all 3 immediately caused an increase in the total short-chain fatty acid production, mainly due to a near doubling in the concentration of acetate and propionate as compared with the control period. So you can see that top number where that total short-chain fatty acid number really bumped up nicely. But here's where it gets a little bit more interesting. In the gut model vessel that was given the 2FL alone, the metabolite profile changed a little bit more right around the 3-week time point. There was an increase in butyrate production, which the other 2 models didn't show. The authors postulated that this was driven by a process called cross-feeding, which I'll describe a little bit more on the next slide, and that it occurred in the 2FL vessel, but not the other 2 vessels, because the 2FL is more bifidogenic than the other 2 treatments. So to go into that a little bit more, first talking about short-chain fatty acids and why they're so important, right? Again, a lot of our viewers probably know this already, but it's helpful to reiterate because they really are important. These are tissue-specific energy and signaling molecules. So they contribute to a lot of functions that affect human health or host health, including effects on our immune system and metabolic functions. Butyrate in particular is a short-chain fatty acid that's particularly important in gut health because it's the main fuel for our intestinal colonocytes. So those cells in our intestinal tract really feed on butyrate. So on the left-hand side of this slide, this is an illustration of that process of cross-feeding. You can see at the top of that illustration, HMOs are being fermented and broken down by bifidobacteria that are using them as a food source. So this creates metabolites like short-chain fatty acids, which are directly beneficial to the host or to us. In addition, the process does create some byproducts, which are metabolites that actually can then turn around and feed other beneficial bacterial species. So that's what you see in the bottom portion of that graphic is that sort of secondary reaction. So those organisms break down the metabolites from the first process into additional beneficial short-chain fatty acids and things that we can use as a host. So it's actually a similar concept to upcycling. The waste products are being turned into something beneficial, and overall the process enhances the microbial diversity further than just the initial feeding process alone. So talking a little bit more about gut barrier function, remember we talked about at the beginning in the microbiome portion of the talk about how important that gut barrier is to our immune system. So in this study, investigators also used permeability assays to show that the 2FL and mixed treatments, but not the LNNT alone, reduced gut permeability, which is a function that's associated with the strengthening of the gut barrier. They used human organoids in a microengineered platform to show that 2FL significantly upregulated proteins that contribute to the development of tight junctions in that epithelial layer. So they demonstrated the complex interactions between the prebiotic HMOs and the beneficial bifidobacteria that feed on them, and demonstrated that the process generates beneficial metabolites like short-chain fatty acids, particularly butyrate, and also upregulated those tight junction proteins, which in turn would lead to decreased intestinal permeability and strengthening of that barrier in humans. So that was the preclinical data. And then there have also been several studies looking at HMOs in humans. So we're going to be talking about that piece next. This article is a really nice one if you want to dig into basically all of the data we have to date around human milk oligosaccharides. It was a systematic review that was published just in August of this year, and the authors identified 26 clinical trials and 5 follow-up publications for their review. Most of these were pediatric. 19 of the studies and 4 of the follow-up publications were with infants up to age 12. And actually the majority of those were in healthy term infants. In adults, there were 8 publications. 2 of these were in healthy individuals. 4 were in populations with IBS. And there were 2 in H. pylori. And among all of the studies, the most studied HMO was 2FL. That was studied in 22 separate clinical trials. So what did they find? In infants, the gut microbiome composition, stool characteristics, and immune responses were shifted toward those of breastfed infants. They saw things like increased stool short-chain fatty acids, reduced fecal pH, and a reduced number of respiratory tract infections and otitis media in infants. In children and adults, the studies also demonstrated the ability of HMOs to shift the gut microbiome. So subjects with IBS who received HMOs demonstrated beneficial changes in the gut microbiome composition, such as increases in the bifidobacterial, as well as improved stool characteristics, decreased severity and duration of symptoms like bloating. And all of the studies showed HMOs to be safe and well tolerated across all of the age groups and all of the health states, regardless of which HMO they looked at and which dose that was given. However, the one caveat there is that doses of 20 grams per day and over in adults were associated with some mild adverse effects, particularly increases in flatulence, rumbling, and bloating. And this really makes sense when you think about the fact that the upper limit of adult tolerance for a non-digestible carbohydrate is right around 20 grams. So that's the dose that they started to have trouble with tolerability. So this is really to be expected. So digging in a little closer and looking at some of the studies that were included in that review, this study was published in 2016, and it was really the first study that provided data on the safety, tolerance, and impact of HMOs on the adult gut microbiome. It was a double-blind, randomized, placebo-controlled study with 100 healthy adults ages 19 to 57, and they received 2FL, LNNT, or a mixture of the two at a 2-to-1 ratio. And they used varying doses from 5 grams up to 20 grams, or were randomized to placebo, all for 2 weeks. The investigators looked at things like blood counts, stool tests like calprotectin, RNA sequencing, and short-chain fatty acids. And then the patients also self-reported their stool quantity and quality using a Bristol stool scale daily, and filled out a 15-question questionnaire about their GI symptoms at screening, entry, and at the end of study. So results for all treatment groups. The RNA sequencing showed that HMO supplementation modified the gut microbiota by increasing the abundance of beneficial bacteria, decreasing the relative abundance of pathogenic organisms, and safety-wise, they found no significant changes in blood work. Some adverse effects were reported by 44 of the patients, and all were characterized as mild, most commonly gas, flatulent, stomach pain, diarrhea, loose stools, and rumbling. And again, as I mentioned previously in the review article, it was really the patients who had that higher dosage in that 20-gram group were the ones who were reporting some side effects. So very dose-responsive side effects there. So this study was published in 2021, and it looked at HMOs and how they affected patients with IBS. So again, it was a randomized double-blind placebo-controlled study of 61 adults with IBS, and investigators were looking to determine the role of HMOs on modulating that gut microbiota. Subjects were randomized to receive 5 grams or 10 grams of 2-FL and LNNT at a 4-to-1 ratio, which is the ratio at which they occur naturally in human milk. That's why that number was probably picked, versus placebo for 4 weeks with an additional 4 weeks of follow-up. The testing of microbiome and metabolites included colonoscopy with mucosal sampling, metabolite profiling, and gene expression analysis. And they found overall that their results supported the assertion that 2-FL and LNNT supplementation modulate that intestinal microenvironment in patients with IBS. They saw moderate changes in fecal microbial composition, and that was really the beta diversity, which is the number of types of organisms, not just the overall number of organisms. Both the fecal and mucosal bifidobacterium species increased, and the intervention modulated that fecal and plasma metabolite profile as well. So changes in that metabolite profile were associated with changes in that bifidobacteria abundance. So they were really looking to see if there was a correlation between the bifidobacteria going up and the metabolite profile changing as well. And they were able to demonstrate that in this study. And another study we're going to talk about is looking at bowel function and GI symptoms, specifically in patients with IBS. So this one was published in 2020 after being presented in 2019 at both UEG Week, which is the European Gastroenterology Week. It's their big GI conference comparable to DDW here in the US. And it was also presented at ACG in 2019. It was a multi-center prospective open-label single-arm trial in the U.S. with a population of 317 by intention to treat or 245 per protocol, adults with IBS. And the objective here was to evaluate the efficacy and safety of a 2-HMO mix. The primary endpoint was change in the percentage of abnormal bowel movements, and the secondary endpoints included changes in IBS symptom score, which is a validated tool, as well as some of the individual parameters of that tool, a questionnaire of IBS symptom severity, and IBS quality of life scores. Patients or subjects received 5 grams per day of 2-FL and LNNT, again at that 4-to-1 mix for 12 weeks. So what did it show? This slide will take you through the primary endpoint. You can see here the Bristol Stool Scale on the right. One of my favorite posters. I always had this up on the wall in my exam rooms when I was seeing patients. But you can see here that judging by the Bristol Stool Scale ratings, the abnormal bowel movements improved significantly from 90.7% at baseline to 57.2% at week 12. So that had a p-value of less than 0.0001. The really interesting thing about this is that the improvement was seen in all the subtypes. So if you look at the chart, in that first baseline, the yellow on top are the more constipated stools, and the blue on the bottom are the more diarrhea type stools. And starting right from that very first treatment visit at 4 weeks, you saw that both types of abnormal bowel movements improved. So the patients who had constipation had improvement, but also the patients who had diarrhea had improvement. There were no differences in the changes between men and women, but interestingly, the patients under 40 did have a somewhat greater reduction in the abnormal bowel movements than the patients over 40 did. And the investigators did not write about any particular reason why they thought that might be, but they did note that that difference was there. So some of the other endpoints that were looked at, these are the secondary endpoints. This one is IBS symptom severity. So you can see that the overall severity of IBS symptoms on the IBS SSS, which is the symptom severity scale, was reduced by 54% on average from baseline to week 12. And as you can see on the graph, those differences were significant at the time of that first treatment visit, which was at week 4, and then were maintained throughout all 12 weeks of the study. Additionally, the pattern was similar among all 3 IBS subtypes. So it didn't matter if they were diarrhea predominant, constipation predominant, or mixed type, they all had that improvement in their symptoms. Now, does this make sense clinically? Absolutely. A reduction of at least 50 points in that total IBS SSS score is what's considered to be clinically significant improvement. And by that standard, 82% of the patients that were in the trial had a clinically significant improvement in their IBS severity over the course of the study. Another of those secondary endpoints was bloating. So you can see on this graph that the HMO treated subjects did see a significant improvement in their bloating severity as well. It decreased by 59.2% overall. And significant improvement again was seen at all 3 treatment assessment timelines and among all of the subtypes as well. And then looking at the health-related quality of life endpoint, you can see here as well that the health-related quality of life score was significantly improved at week 12 compared with baseline, with those scores rising from 50.4 to 74.6 by the end of the study, with a p-value of less than 0.0001, so highly significant findings. And again, there were no differences among the 3 IBS subtypes in the change in those quality of life scores. So what about safety? This is something that's always really important to look at with these studies as well. And the investigators concluded that HMOs are safe, tolerable, and effective. Overall, there were no serious incidents causing safety concerns in this trial. Generally, patients reported that the intervention was well tolerated. The number of total adverse events that was reported was very low. Most of them were related to the GI tract, and the most common side effect was gas, followed by abdominal distension and abdominal pain. There was 1 serious adverse event during the trial, but it was considered on review to be unrelated to the intervention. So overall, the authors concluded that HMOs reduce abnormal stool consistency, improve overall bowel symptom severity, reduce pain and bloating, and improve quality of life. And they noted that they had a beneficial effect for all of the subtypes, genders, and ages studied, with that one little exception of those patients under 40 having a better effect for the reduction of abnormal stools than the older patients. So that's the data on HMOs. Questions before we move on to the Bacillus coagulans unique?
Yeah, if you don't mind, Alex, I'll go first. So I had a question and comment, but I want to start with my question. With all the studies that have been looking at HMOs, have any of them discussed whether individuals who stop taking HMOs, if they keep the benefits for a certain period of time, or do they kind of return or revert back to their symptom presentation, or even going back to that previous microbiota makeup?
Mm-hmm. So most of the studies are over a shorter period, like up to 12 weeks, and some of them had a little bit of a washout period afterward, but the majority of the studies did really look at that shorter term interval. So it would be great to see some longer term studies and also look at what happens, you're right, when they stop taking them.
Yeah, for sure. And the other thing I just wanted to, I guess, comment, I don't think it's necessarily a question, but I think a lot of people, when they're working with individuals with IBS, they're kind of a little bit more hesitant to recommending prebiotics. But it sounds like in the studies, a lot of the individuals that were studied had IBS type symptoms. And so it seems like might be this type of prebiotic might be, if we're thinking about working with patients with IBS, maybe HMOs or 2FL might be kind of the better one to use in this particular patient population.
Well, you can note from the studies that in the lower doses in particular, they really were very well tolerated. And it was really only once you got up to that 20 gram per day and higher dose that the patients started to have some of those symptoms. But absolutely, I mean, you think about prebiotics, you think about typically highly fibrous substances, and those do tend to be less well tolerated, particularly by patients who might already have things like gas and bloating to start off with.
Great.
So actually building off of that, we had talked earlier about the fact that 2FL was the most studied of the two, but I think the three that you just went through were all based on combinations. I think usually in the 4-to-1. Can you speak a little bit to why would 2FL be the primary choice of the two if most of the research is in combination with both?
Yeah, so there's a couple of different reasons for that. One is actually that of the two, the 2FL seems to be the one that has the lower side effect profile. So the LNNT did seem to create a little bit more of that bloating for patients. So that is one of the potential reasons to choose the 2FL alone. And interesting, there's another study that I didn't present today because it's a study in children, but it was a study that looked at 2FL and LNNT as well as a mix as well, similar structure to some of these other studies that we talked about today. And in that study, it did also show that 2FL alone was as good as or better at increasing beneficial organisms than and increasing production of short chain fatty acids than the LNNT alone. So looks like it works very well, even on its own, and potentially better tolerated. So that would be, a reasoning behind choosing one versus the other.
Okay, super. We'll take maybe two more questions here, and then we'll move on to the next section. And for those that we don't touch, we'll get to at the end again, if we can.
Yep.
So there's a question here about going back to symptoms and adverse reactions to HMOs. If a patient is already responding poorly to a 2,000 milligram or 2 gram dosage, would you have a titrated approach to dosing? Like, would you start at a lower dose than that and gradually increase over time?
If they were having some symptoms at the lower dose?
The standard dose, it seemed like, was about 5 to 10 grams or so, correct? Yeah. So let's say they're already having adverse reactions at a 2 gram dose. Would you suggest starting at a lower dose and just gradually increasing?
It certainly wouldn't be an unreasonable approach. One of the other things that you might want to consider, though, is looking at where else they might be getting some of those substances in their diet. For example, if the issue is really a lactose issue and they're getting some lactose that they didn't realize somewhere else in their diet, potentially cutting that out might increase the tolerability. But again, the overall lactose content is so low that most patients aren't going to have an issue with it.
Natasha, do you want to take one of the other questions that are coming in?
Yes, sure. A great question here. Someone's asking if somebody's already on a prebiotic supplement to improve low commensal strains, would you recommend an addition like in the HMO, like assuming that there's no HMO in this prebiotic, would you assume kind of having that layered effect, one or the other?
Yeah, that's a good question. It's not something that I've seen in clinical studies, so I think it would really just be a matter of trial and error with a patient. You certainly wouldn't hurt anyone by doing that, but I don't have any data to back it up.
Okay.
Let's keep going. There's more questions coming in, which is great, but we'll address those as we go.
All right. We have another section to get through. So that's talking about Bacillus coagulans unique IS2. And this is a different kind of probiotic from what many of you have probably seen before. So this is a spore-forming bacterial species, which means that they have a natural protective spore around them, which enhances their survivability in any environment. The spores actually help the bacteria remain dormant for years in the absence of air, water, or nutrients. So you can imagine it makes them pretty tough. B coagulans produce lactic acid, just like more well-known strains such as lactobacillus and bifidobacteria. They also germinate and proliferate in the digestive tract where it becomes metabolically active. When compared to other strains, B. coagulans is more stable even under extreme conditions like high heat, acid, and bile salt. And it can resist stomach acid, so they can easily survive transit through the stomach into the intestine. They can grow in a highly alkaline environment as well and withstand stomach acid. They can withstand extremely high temperatures as well. So really a tough organism that can survive a lot of conditions, which makes it ideal for using in human populations. Also makes it very shelf stable, which is nice. So looking at some of the clinical data behind B. coagulans. So this was we're going to discuss two different studies looking at this organism, both in adult populations. So this was a study that was published in 2019. It was a randomized, double-blind, placebo-controlled study in adults with IBS. They had an interesting approach to patient screening. They initially screened 153 patients and then gave them all placebo for 2 weeks to see who was compliant. And then they randomized the compliant patients, which I thought was a really creative and unique approach. But they were randomized to receive either the placebo or the probiotic for an additional 8 weeks. And then they looked at primary endpoints of pain intensity on an 11-point numerical rating scale and the frequency of complete spontaneous bowel movements. They also looked at some secondary endpoints, including symptom severity, stool consistency, and patient and physician global assessment, as well as serum biomarkers and safety parameters. So just diving into some of those results here. These are the pain results. On the left side is pain intensity. So you can see that abdominal pain on a 1 to 10 scale. In the probiotic group, they showed significantly lower abdominal pain intensity at week 8 and week 10. There was a reduction in pain as well. Patients who experienced at least a 50% reduction in pain from baseline were significantly higher in the probiotic group than the placebo group, and that's shown on the right-hand side. Next slide here is looking at the stool outcomes. So the bowel movement frequency and consistency. On the left side, it was that BM frequency, which was one of the primary endpoints. And they were looking at the number of complete spontaneous bowel movements. That score was numerically higher in the probiotic group at the first visit, which was week 4, and it reached statistical significance in the probiotic group at week 8 and continued through week 10. On the right side, you can see bowel movement consistency, and the stool consistency of the subjects in the probiotic group was significantly improved after 6 weeks of treatment, with 65% of those patients gaining normal stool consistency versus only 33% of those in the placebo group. So this was significant with a p-value of less than 0.001. So this one looks at the subjective measures, so the patient and physician global assessment. You can see in the probiotic group, 84% of the patients on probiotics had either complete or considerable relief from symptoms at week 8. In the placebo group, 0 had complete relief and only 11% had considerable relief at the same time point. The physician assessment on the right-hand side was very similar in appearance to the patient assessment, which is good. It means that physicians were doing a good job of understanding their patient's symptoms. Other parameters they looked at included rescue medications. So they found that the patients in the probiotic group actually used less rescue medications than the placebo group. And with regard to safety, no adverse events were reported in either group. This next study here looks at B. coagulans unique IS2 in patients with constipation. So this one was published in 2020. It was another randomized double-blind placebo-controlled study looking at adults ages 18 to 64 with functional constipation. They received either 2 billion CFUs or placebo for 4 weeks. And the primary endpoint was efficacy, looking for 3 or more bowel movements per week, with secondary endpoints being stool change in frequency, consistency, difficulty of evacuation, defecation pain, and abdominal pain. And then they also looked at safety endpoints. So results from this one, the primary endpoint, which was bowel movement frequency, On the chart, you can see that the darker bar is the B coagulans treated group and the lighter bar is the placebo group. And you can see that by week 3, the probiotic group showed significant improvement in frequency over baseline compared to placebo, with bowel movement frequency increasing from 0.9 spontaneous bowel movements a week at week 1 to 5.98 at week 4 in the probiotic group. Now, the placebo group did also have an increase. They went up from 0.94 to 3.12 spontaneous bowel movements a week. So this was a decently high placebo response. But even with that high placebo response, the delta was still highly significant with a p-value of less than 0.001. So looking at some of those secondary endpoints, this slide's really busy, so I apologize for that one. But basically what it comes down to is that the stool consistency, the defecation pain, incomplete evacuation, and abdominal pain scores were all statistically significant at weeks 3 and 4. When it comes to safety, no serious adverse events were reported, although 3 patients in the placebo group did report some mild AEs, including headache and fever. Overall, the investigators concluded that B coagulans unique IS2 can be used safely and effectively in the treatment of patients with constipation. So to sum it all up, today we've talked about how digestive issues have a significant impact on patient well-being, how the microbiome plays a really critical role in maintaining the health of the GI tract. We've discussed some of the factors contributing to dysbiosis and how that can potentially exacerbate GI symptoms. And we've talked about how there are multiple pathways to supporting the microbiome, including pre and probiotics, as well as combining them together with a synbiotic. I introduced you to human milk oligosaccharides, which are a human-derived prebiotic, currently generating a lot of interest for its potential benefit beyond just the infant population, but into adults as well, and talked about some of the preclinical and clinical research around that, and then a look at some of the data around Bacillus coagulans unique IS2, features that make it unique, and some of the research around that organism as well. So, questions?
We have lots of questions. Maybe we'll just take a few before we move on.
Mm-hmm.
Okay, I have one here regarding if you've encountered any research for, they specified here for human milk oligosaccharides in regards to like SIBO or CFO, so fungal overgrowth. And I think there was also H. pylori somewhere. Somebody was asking if it can be used to kind of address those conditions or in the context of those conditions.
There are a couple of studies that were done in the adult population receiving antibiotics for H. pylori. So there is data out there on that. With regard to SIBO and CFO, I have not seen any studies on those conditions yet. So you'd have to think more about mechanism of action and what you're really trying to accomplish with HMOs and with probiotics and their effect on the microbiome in patients who have those conditions.
Sorry, Amy, just to clarify on the H. pylori question, they were specifically also asking about if somebody has an intolerance to dairy with H. pylori. You addressed this more or less earlier, but the concern there is that they can't tolerate dairy due to lactose intolerance. Will they be able to tolerate HMOs in this case? And I think you had said earlier it should be okay.
I'm sorry, you were breaking up a little bit on me there.
Oh, my internet's breaking up again. No, just quickly, the question was with regards to H. pylori, if they have a sensitivity to lactose, would it be okay to take HMOs in that case? And I think that probably goes back to your answer earlier as well.
With regard to the lactose intolerance, yeah. And certainly if you're tying that in with H. pylori as well, was that correct?
Yes.
Sometimes the lactose intolerance is really a secondary lactose intolerance rather than a primary one. And so, again, it's difficult to judge the actual amount of lactose that they could tolerate, but hopefully by correcting the underlying condition, you would improve their tolerance of lactose anyway. I don't know if that helps.
Yeah, I think the answer seems to be probably that there's not a definitive study to confirm that, but it would be more a bit of trial and error, knowing that this is not likely reactive at lower doses with people with lactose intolerance.
Correct.
Perfect. Let's maybe do one more, Natacha, if you want to take it, and then we'll we'll get through the next few slides and then we'll have some Q&A at the end.
Yeah, for sure. Next one I have here is, and I think as you presented the studies, this came up, but people were just wondering if, I think this was in the context of HMOs, if there have been studies in patients that didn't have IBS. So they had gas or diarrhea or bloating, but it wasn't in the context of an official IBS diagnosis. So I guess would HMOs help with that demographic?
Yeah. The studies that were done in adults, again, there weren't that many, there haven't been that many of them so far, although there's more ongoing. So there were 2 that were done in healthy populations, but those were really meant to be safety and efficacy and dose ranging studies. So they were looking to see what doses were tolerated and then also looking at side effects. So they didn't actually specifically look at the GI symptoms that those patients were having per se. So I can't really speak to that.
All right, shall we move on?
Let's move on and we'll come back to the other questions at the end.
Yeah, because there's still, people are very engaged. It's great.
Yeah, love it. Keep them coming.
All right, so Oligos was actually originally created by a Danish biotechnology company founded by 6 European carbohydrate chemists back in 2005. It joined the iHealth family in 2020. So iHealth is an American company. It's based in Cromwell, Connecticut, which is a wholly owned subsidiary of DSM-Firmenich, which is a global consumer health and wellness company. We develop, market, and distribute branded products that support health and wellness. And our dedication to quality is really a commitment that's solidly backed by quality ingredients, stringent quality control measures, and continuous improvement through research and innovation. So we really believe in best-in-class formulations and rely on science to support our brands. And the mission statement of the company is that we exist to serve unspoken and overlooked health issues so that people can live life to their full potential.
Sorry, just having an issue unmuting there. Thank you so much, Amy, for going through all of this research on these 2 really novel ingredients that hopefully people can start applying and using in their practice. I am just going to go briefly over some of the information that can really help practitioners really take that to practice tomorrow and start utilizing these, again, really unique ingredients. So as Alex mentioned at the very beginning of the presentation, we did put together a protocol that includes human milk oligosaccharides and also probiotics in general, but we do have in this particular case the coagulans as well. So here we have some evidence-based ingredients. So if you're not familiar with our protocols, and they're also known as templates, what we do in our protocols is that we highlight 5 top key ingredients that are evidence-based to support that particular ingredient, that particular condition. So here we have chronic digestive discomfort, which you can also falls within the IBS realm. So really helping with that constipation and abdominal pain. So those are kind of the key, I guess, symptoms that this particular protocol are addressing, but also can also help with some diarrhea as well. So we have, like I mentioned, the human milk oligosaccharides, ginger, peppermint, and then probiotics, and then as well as fiber. Now, what I do want to mention here in the context of our protocols is that you'll always see the citations for our protocols, and also our doses are also always based on evidence. And you can find these protocols within your account. So you can go into your account, you can look at the chronic digestive discomfort protocol, you can apply it to your treatment plan, and then from there you can modify at will. So if you only want to do the HMOs to start, you can do that, or HMOs and ginger, depending on your patient presentation. So the protocols are really versatile, and they really kind of save some time in looking for the products that are associated with the ingredients. But like I said, they're completely modifiable, so you can also change the products associated to the ingredients. And I just want to mention that we do have a QR code if you want to access the protocol right now, so you can scan that. However, if your phone is not with you, we will be sending the protocol in the post-webinar email, so you'll also have access. And like I mentioned, it is in Fullscript in regards to going to the template section. So you could always find that there. And another way that you can look up these ingredients is that you can actually search for these 2 novel ingredients in our catalog. So you can write 2FL, B coagulants, or the long version of those ingredients, and you will find the appropriate products that fill those criteria. So it's a really easy way to find what you're looking for. And I think just the last bit here is if you want to learn more, if you want to learn more about Oligos or these 2 ingredients, we created these toolkits for you that basically assemble a bunch of different assets that you can help, again, learn more about these ingredients, about Oligos, and how to apply this in your practice. And that was my 2 minutes. I think we just have a whole list of references, so you do have access to this slide deck in the handout section. So if you want to look at any of those studies, they're all hyperlinked throughout the presentation, all summarized at the very end. 1 minute to spare. Do we try to answer a question?
Yeah, let's take 1 or 2 more, and then if there's any unanswered questions, we can follow up as part of the follow-up email with answers to those as well. Do you want to take 1 or 2 more there, Natasha?
Let's see.
I'll quickly jump in then with one. So Jenny is asking if patients with the FUT2 gene mutation were looked at in any of these studies. That's a pretty specific question, Amy. Do you happen to know any of the studies?
That's a very specific question. It's not something that I saw in any of the studies, at least the ones that I reviewed really closely for this talk, but we could certainly go back and take a look.
Okay, maybe we can follow up on that one. That's quite an interesting question. At least it might be interesting to answer if there's no specific studies what the potential implications would be if someone had a mutation like that taking place.
Right.
Yeah, we'll maybe do 1 more. Natasha, do you want to pick one?
So someone's asking, how does the B coagulans strain differ from other commonly used strains? So they mention the lactospore and Lacris 15.
Mm-hmm.
Yeah.
Well, specific strains have specific benefits. So what you really want to do when you're looking at strains of probiotics is match your strain and what the clinical data is around that strain to the benefit that you're looking for. So that's one piece. And dosing actually ties right into that as well, right? Because different strains are found in different doses and are beneficial at different doses. So again, 2 billion CFUs of one particular strain might be beneficial, whereas in another strain, it might have been studied at 10 billion or 20 billion CFUs for its beneficial effects. So that's something to remember when you're looking at the different strains. But as far as actual strain characteristics go, the fact that it's a spore former is one of the things that really makes it unique. And those properties of the spores that really cause it to be a very tough and resilient type of organism. That's really one of the very unique things about this organism.
Perfect. I think that's actually a great way to end. We see Amy coming back in here, making sure we stay on time. I will say quickly before you finish off, Amy, that I think that's such a great point to end on, Amy Harvill, that when it comes to supplement ingredients, it's not just about the ingredient in general. It's very often about the dosage and the form specifically for the clinical outcome that you're looking for, which is exactly why we started by saying we want to lean more into the ingredients and the evidence behind them and the products that associate those ingredients in a way that's therapeutically beneficial. So with that said, I'll quickly say thank you very much, Amy Harvill, for being here. It's been a real pleasure hearing you speak, present on all this, answering all these questions. For those of you whose questions we were not answered, we'll follow up after the fact and send those as well. So now I'll pass back to Amy Reagan.
Excellent. Thank you so much, everybody. And thanks to everyone who attended today. And also extra thanks for Amy, Alex, and Natasha on this presentation and all the work that went behind it. Everyone look out in their email for a link to view this recording. We'll send that in the follow-up. And anyone who has any additional questions can send them over to me. My email address is amy.regan, R-E-G-A-N, @fullscript.com. I hope everyone enjoyed this presentation and has a great rest of your day. Thank you so much, everybody.